I'm Ben, and this is Josh at Brown Dog Gadgets. Today we're going to be doing a little bit of stress testing on some conductive tape. So Josh, where did the idea for doing this come from?
Well, we have a lot of customers use our conductive tape for all kinds of projects, and we get frequently asked, how much power can our tape safely handle? And we honestly just don't know. We use tape for lots of stuff, but we never really go above half an amp of power on our tape. So it'd be kind of fun to figure out what's the upper limit that our tape can handle.
Because literally, this would normally be powering like 1 or 2 LEDs, something like that.
Typically, the papercraft people do, yeah, it's 1 to 2 LEDs, maybe 5 to 10, which 300 milliamps is not a whole lot.
That'd be a big project, though, really big.
Yeah, it would be. And honestly, you're pretty much always using CR2032 batteries, which only put out 15 to 20 milliamps of current at a time. Maybe AA's will put up half an amp of power. So I'm just kind of curious, how much can we throw at this thing before it starts to become unusable?
Okay, so in front of us we've got a couple different devices. We've got a power supply down here. Now this device here is just something that can put a constant load to draw plenty of power out of that power supply then.
Yeah, typically you can find these all over the place, eBay and Amazon, for testing batteries. It just constantly draws power and gives you a readout of how much current's been used over time. And it's just perfect for our situation because we can really dial in exactly the right amperage for testing.
Okay, so essentially we'll have our power coming from the power supply here. We'll be putting a steady current. We're going to go up to, what, 5 amps?
Max of 5 amps off this thing, though I don't know if the tape can handle that much.
So the tape itself right here will be part of the circuit, and it's literally going to be the weak link. It's going to be kind of like a fuse, basically. At a certain amount of current, it's going to fail. It's going to stop working.
Exactly.
Okay. Well, do you have any predictions for the different types of tapes? We've got 3 tapes here. Can you tell us about them?
So we have our standard off-the-shelf copper foil tape that, gosh, I used back when I was teaching 10 years ago. You can find this everywhere. I'm pretty sure this won't do anything. Like, we won't have any issues because it's just pure copper, and copper is such a great conductor, and the resistance across this is so low in general. Now we have our MakerTape, which is what we love to use for projects, which is a nylon tape. It's much stronger, flexible, sturdier, and possible to break, but it's also nylon. So there's not much resistance, not any more resistance than the copper foil. However, there's hot spots we'll probably be able to pop up here and there on this guy. And yeah, this is what I'm wondering if this has a max amount it can handle, especially from the impurities between the nickel, the steel, and the nylon in place here. We also have an 1/8 inch version of this as well we use for projects. So this will probably handle less than this one can.
So really what's going to happen here is it's current that creates heat when it meets resistance in an electrical circuit. So I've got a little thermal attachment for my phone that I brought with. So I'm hoping that we can actually see the tape heat up while it's doing that with the thermal camera, although these are all shiny materials and those do sometimes cause issues with essentially heat reflections for thermal cameras. So we'll just have to try it,
exactly,
see how it works.
Our little tiny laser heat gun wouldn't work on the tape because it's way too reflective to pick up a signal, so ended up with some weird signals doing some testing earlier on it.
Okay, so why don't we get our circuit hooked up? We've got a couple of cameras so we can point at our power supply just to see how much current is being drawn at any time. We'll get a close-up on the tape and see what happens. Now, of course, this is over the top. We are intentionally putting way too much current through this.
Oh goodness!
This is, you would never do this on a typical project. I mean,
yeah, we're going to be going 20, 30, 40 times higher than anybody I've ever known has done with the tape.
This is not the amount. This is way more power than you would ever draw from a little tiny battery on a light-up greeting card or a light-up shirt or anything like that.
I think the most we ever threw the tape on a project was maybe half an amp at 5 volts, maybe briefly, but that was perfectly fine, and we're going to go up to 5 amps. So.
Okay, and of course, safety first. So no joke, we do have the fire extinguisher right here. This stuff gets hot, burns. We'll have to be a little careful of that. But,
yes, indeed.
Let's put some current through this, see what happens.
Yeah. So right now we have our 1/4 inch MakerTape, which is a nylon conductive tape, hooked up here at about a 1 foot distance between these 2 pegs. So we're going to start out and pump about 1 amp into it first to see what happens, because that's probably the max that anyone's ever going to do with this, and with any kind of projects that they would reasonably want to do. Even that's kind of on the high end. So we're going to just touch the little knob here and just kind of dial it into about 1 amp of current. There we go, about 1.1 amp.
And already I'm seeing that start to heat up. Yeah, it's probably...
Oh yeah, I can feel it when I put my hand next to there. It's not burning hot, but it definitely is heating up. So for a comparison, this would be doing about 100 LEDs in parallel if we were doing this. Those little standard 5 and 10 millimeter LEDs. Typically those draw between 6 and 10 milliamp of draw, especially when they have a resistor on them. So this would be probably about 100-ish of those LEDs running off of one strip of tape in parallel. Oh yeah, that definitely is getting a little toasty there. How the thermals look, Ben?
It's definitely warmer. We can definitely see that, and that constant load over there is also a thermal device. That's how it can waste so much power. So we can see that's got a fan to keep it cool.
But the funny thing is, if you feel the end of this tape just a couple inches away from our leads, I'm not feeling any heat down on the ends. So it's definitely not transferring the heat very well, which you probably would see that happening more in the copper foil tape as being pure copper.
And we can see this on the thermal too. If you move your hand back, actually it's warm from your hand touching it. But yeah, it's warm on the side where the current is flowing, and it is cooler on the side that, actually, let's look on the other side where your hand wasn't touching. Over here, we got heat from those leads, but actually, like right where just the spare tape itself, it's cold.
Well, that just tells us that the tape is a good conductor, but not a good heat conductor, which makes total sense since it's nylon, nickel, and steel as a mixture in there.
Okay, so this tape, it definitely got warm, but that's it. I mean, can you still touch it?
Oh yeah, this is, I'm in no way, yeah, feels room temperature-ish. It does not feel bad at all.
Okay.
So that's definitely an amp. It'll get a little warm, but it's not going to cause any issues. And we've had this on for a minute or so, and yeah, I can...
So nothing's happened. It's not going to start on fire. It's not going to break.
No, well, let's see what happens when we bump it up to 2 amps, which would be 200 plus LEDs hooked up to it, which is way more than anybody would actually want to do with conductive tape, at least off one power supply. So we're going to pump this guy up to just at 2 amps, and we can dial that in.
I think it just heated right up. It's nice and bright on the thermal. All of a sudden, that's the brightest thing on the screen. It's warmer than you are now, Josh.
Oh, good. So it's at least 100 degrees there.
So I probably don't even want to touch. Oh, I can feel the heat coming off that.
Now I did bring with me
that is warm.
A meat thermometer that we can poke at it and maybe get see if I can get any sort of reading off of here, since any other thermometer we own doesn't go up high enough. So let's see what the Mr. Meat thermometer says.
And I just flipped on the thermometer feature on my thermal camera, and unfortunately, I can't really get a reading off of that because it's sort of too skinny. I don't have the detail I need to get the hot spot.
The meat thermometer is already up at 93 and rising. Fahrenheit, in case anyone cares. 98,
It's
100, 102. And
you know, actually on the thermal, if I touch it, it gets my fingers warm. My fingers are actually cooling it down. The heat's being transferred from the tape into my fingers.
the thermometer says 106 right now.
Which is, you know, that's like hot tub warm, but it's still not going to burn you.
Yeah, 105, 106 Fahrenheit. Yeah, that's, and 2 amps is well beyond what anybody would ever reasonably do. Yeah, 200 LEDs plus would be would be quite a bit. So let's take it up to 3 amps and see what happens when we hit 3 amps, if we can kind of get above 105 degrees, or if something else weird's going to happen.
Turn that, well, or do you want to just go straight up to like 5 amps?
Let's try 3 and then 4 and just see what happens quickly, because if it burns out, I want to kind of know where it...
Right, what's the point that something happens, so.
So we're just about 3 amp of power here. I can definitely smell something happening with it. I can smell like a little bit of burnt something. It could be the adhesive on the back side.
Oh, yeah,
there is
definitely.
a conductive adhesive on the back of the MakerTape.
I'm smelling that.
So that's probably like a burning glue smell, because the nylon itself, nylon melts at about 428 degrees Fahrenheit. So I don't think we're going to see the nylon itself melt. However, the adhesive, I have no idea exactly what's in that, being just glue. And so let's try the old thermometer here, see what we can get on this guy. Oh yeah, that's going up fast.
Yeah, I don't really have the accuracy on the thermometer on the thermal camera, but I can see it's definitely hot now.
Well, the meat thermometers...
I mean, it's reading over 100 when I can at least get the...
The meat thermometer says 143 right now and rising. Oh
So
no, do we max out 143?
let's see, you got to get to what, 160 for fully cooked pork, right?
I think so, yeah. At 153, 154 if I'm giving a little
Your
pressure.
steak is well done.
So we're close to 160 in the middle. Oh gosh, 160.
It looks like it's getting hot fast on the thermal.
So this is the point where we probably shouldn't be touching it anymore. Yeah, we're getting 165 on the meat thermometer, and it's going up more. Now, as we talked about before, as heat increases, so does resistance, which is just this feedback loop, which is then going to make it get hotter. So, yeah, 160-ish, that's a lot. And it could be, too, we could have hot spots on the tape itself.
And we're using 2 different styles of thermometer, and I mean, frankly, that one's designed for the kitchen, not for the lab.
Yeah, and this was the only thing I had that would go up high enough that I would figure would work. So thanks, Weber, for your wonderful meat thermometer in this experiment. Well, Ben, we're at 3 amp. Should we bump it up to 4 and see what happens?
Absolutely.
All right. Let's make some more interesting smells. Oh, it burned out on us.
It broke?
Yep,
Where'd
it broke.
break?
So,
Oh, and actually, we'll see it cooling down now on the thermal camera, because since the circuit's broken, there's no more current.
so what happened is we have a spot right here where the tape just broke across the
Oh
middle.
yeah, it's cooling down real fast.
Yeah, so it basically, like a fuse, it broke. So
Exactly like a fuse.
this is what I kind of figured might happen, is that we'd end up with a hot spot that would cause a break of some kind. And we actually heard a little sizzle. I heard a sizzle.
Yeah, I heard a little something.
So something went on there where it just went out. So yeah, that's good to know. If you ever try to pump too much power through this tape, it'll just break like a fuse. So that's always handy to know.
So frankly, if something really bad happens, the tape just stops working. There's no more power.
Yeah, it's a built-in fuse.
Built-in fuse.
And that was 3.5 plus amps that were going through the tape when it actually hit that, and that would be, gosh, 350 plus regular LEDs on there at least, if not more. So that's a pretty insane amount of power going through there. I mean, your typical iPad charger runs 2.5 amps, and that's for charging an iPad off of the beefy Apple adapter. So yeah, well, that was a break in the tape. We could try this again at a shorter distance and see what happens with that.
Because in a shorter distance, it's less tape to dissipate the heat, so more heat in a smaller area.
Yeah, and we're more likely to get a higher amperage because there'll be less chance of a burnout like that.
Okay, so what do you want, like 3 inches instead of 12, something like
Yeah,
that?
let's try about 3 inches. 3
Okay.
inches seems like a pretty standard small amount of tape for a project. There was a foot there. So yeah, 3 inches seems about like a good amount. Now we're going to do the exact same thing, but only at a length of 3 inch, which should be interesting. We're going to actually pop it up right up to 3 amps right away, since we know that at a foot it handled 3 amps perfectly fine. So we'll just go directly there. So there's just about 3 amps of power.
Yeah, it's getting nice and warm right away, real quick.
So how about this? I'm just gonna, since we know it'll handle 3 amps fine, we're gonna just go up to
You might not want to touch it. It's looking hot already.
Huh?
I can smell it.
We're gonna bump it up to 3.5 because I like to live dangerously. There's 3.5.
Oh, I just heard it.
There it burned out again. So yeah,
Same thing.
So about 3.5 amps, it'll fuse itself. It'll cut the current by burning out randomly. And again, there's just a nice little line there where the tape fizzled. We heard a pop as well.
Yeah.
So you have to see what happens with the other tape. Now we've got some 1/8 inch of the nylon MakerTape. This is what we typically use with Lego projects with our Crazy Circuit system. So we usually don't do very long chunks of MakerTape on Lego, but occasionally get up to like a foot or so if you're making a big project. And even then too, we're doing a few LEDs or a piezo speaker or an Arduino off of there, which isn't pulling more than 1/4 to 1/2 an amp. So we're going to do this up to 1 amp just to start with, because that seems like a max that anybody would reasonably do with this tape. And the 1/4 inch shouldn't have any issue, so I have to imagine this wouldn't have much as well, especially when it comes to heat.
And we see a little heat right now, but it doesn't look like that much.
Feels ever so slightly warm to me. Oh, there is a hot spot. That was surprising, because the rest of it felt just fine until I hit a random spot there in the middle.
Oh yeah, looks like there, I can kind of see just like one, I don't know, weird little something in the middle maybe.
It's probably, honestly, probably just a little bit of imperfection in the nylon or the metal that's there, which makes sense considering this is a mixture of nylon, steel, and nickel.
Well, crank it up another notch.
Yeah, let's go up to 2 amps, because that was perfectly fine, if not hot, on the 1/4 inch.
But we only have half the width now, so we're not going to be able to dissipate the heat as fast. And absolutely, I see that heating up on the thermal.
Let's check out the meat thermometer here.
160-ish, I'm getting.
Which would make sense. Yeah, the meat thermometers are up to 110, 115, 120.
Yeah, I'm getting as high as 180 some.
That would make sense if you found a random hotspot. Yeah, if I move it along here down to 145 over in this random spot here in the middle versus 130, a different spot.
And again, 2 different thermometers, 2 different styles of thermometers.
Yeah, well, that totally makes sense. Great. So yeah, 2 amps, you'd never want to do that. That's enough to melt some stuff. For comparison, typical 3D printers run about 200 degrees, 190 degrees centigrade, which is, I don't know what that is in Fahrenheit. What is it, times 2 point?
You smelling something right now?
Oh yeah, I'm smelling.
Smells like hot glue right now.
It's the adhesive. It's got to be the adhesive on the backside heating up, and yeah.
Take it up another notch.
So let's try 2.5 amp, because I know at 3.5 our other tape consistently broke. Oh, yep, I heard a snap when we hit about
Right in the middle.
2.3-ish, and I can actually see it, yeah, right there.
Yep.
There's a little spot that just broke. So 2.5, which isn't bad, which totally makes sense if it's...
Just popped right in the middle.
Yeah, well, the other stuff broke at 3.5, 3.3.
The tape cools down really fast too. I mean, it's cold basically.
Oh, that was... Well, there's a
Real
lot of
fast.
surface area on
Real
the
fast.
tape because it's a woven fabric. So more so than just the copper foil, for instance. There's a lot more surface area to
Right there. And actually, because it's tight, it's sort of pulled open a little bit too.
You can see
Which is kinda
the
neat.
Well, you can see the wax paper backing on there. If we
Yeah.
took the backing off, this thing would have fallen apart.
Yeah, I was exactly just thinking that. So there it is. So far our catastrophic failure is the tape breaks and it works like a fuse. So it's actually more of a safety feature than a danger right now.
It's a feature, not a bug, Ben.
It's a feature.
We'll try this one more time, but at 3 inches on the 1/8 inch tape, and see if we can't get something interesting to happen with it. We're going to pop it up to 2.5, or close to it. We'll just gradually do it this time. Maybe add some dramatic music in here.
Ooh. Heard that time. It made a little crackle sound.
Yeah, I saw a spark off it too there.
Yeah, there's just like a little tiny dark spot. And again, cooling off pretty quick as well.
Well, you had mentioned, Ben, that you had wondered if the wax paper on the back was causing any issues with our
maybe
with our
holding
readings.
the heat in or not. I don't know.
Yeah, so why don't we just give this another try again, but without the wax paper on the back side, just to see what happens. They may also look dramatic falling off as well. We definitely have plenty of tape here, so we'll give this a whirl again without the wax paper on the rear. We've taken the wax paper backing off, which is just there to keep it from sticking to itself on the roll. And we're going to see if it can go a bit above that 2.5 amp we were getting at before, or if something else will happen.
Crank it up.
So let's just...
And we see on the thermal. Whoa.
and then it broke apart right away.
Wow.
Yeah, that 2.4, 2.5, like that took no time whatsoever for that guy to pop.
Huh. So do we think the wax paper was... Why would the wax paper actually allow more current going? Yeah, just pop it over a little.
Let's do that. Let's see what happens again.
Okay, it's warming up. Oh, a little tiny spark and that's
Yeah,
it.
2.5.
That's it.
So, I mean, 2.5 is pretty good for an 1/8 inch piece of tape. That's interesting. Heck, why not?
How about we just do one right up at 5 amps?
Sure, we'll
Why
crank
not?
it up all the way to 5 right away.
We've
There's
got-
a little piece of nylon holding it all together. I'm just going to pop that. Yeah, that didn't take long.
Okay, what do we got going on here now?
All right, so we have an idea, we have a theory that because the tape is suspended, that there's a bit of pull on it just from gravity, that might actually be contributing to it breaking very easily. So we're going to try just some bit of tape on the wood here and just see if we can just crank this 1/4 inch up to a bit higher amperage. So we're just going to go right all the way up to...
Warm right away on the thermal.
Yeah, we're here at 4.97.
Oh, I heard a crack. Okay, same thing. It just like kind of boom, made a little a crack. It just broke like a fuse.
We're going to keep trying this till we get a burn, Ben. Because we need a burn, because we had a die at 3.5 last time. We did a long strip. So there's a little over 4.
And it's definitely nice and warm right now. Very clear on the thermal.
Oh, it's warping. Yeah, it was physically warping there.
Ooh, I smell that. It's kind of, yeah, the edges kind of shrank in a little bit.
Yeah, you could see the maybe it was the wax or something, but it was definitely...
Okay, so that was at 4 amps?
That's at 4 amps.
Okay. Let's try another one, maybe like 3.5. Let it bake for a while.
There's 4.
I can smell it.
Oh, it's warping. And there...
And bzzzt.
All right, let's just crank this guy up.
And again, it warms up right away pretty quick. And I heard a crack and done. Josh, these are looking more like safety devices than things that burst into flames.
It's not even hot as I'm touching it here. I can see it warping.
Little tiny flash and crackle, and that was it.
You can see it deforming right away on here at 4.
I mean, we can see some nice bright heat. Yeah, oh.
Snap, crackle,
And
pop.
It's done.
All right, we'll just try the 1/8 inch here. See, we can't make this puppy red hot.
Nice and warm right away, of course. And it's done. 3 amps. And bzzzt.
This is right at 3.
And bzzzt.
Actually,
I saw a puff of smoke on
I
that
knew
one.
that was going to happen because there's a little tiny crease in the tape right there.
Right, so it's going to be weaker. Well, 3.5 amps and nothing's happening other than that it's warm.
Yep. Now this is the stuff that was burning out a little bit higher. Well, actually 3.5 is what burned out last time.
Yeah, I thought it was usually around 3.5, so we're already a little beyond that. Oh, it's got to be nice and warm right now.
I see it getting dark in the middle there. Oh, it's bubbling. It's smoking.
I smell it. Smoke. Woo!
That was a very small amount of flame on that one.
Smells bad though.
It does. So, okay, it totally can happen.
That was our biggest excitement.
The best one was just this morning, honestly. The best one was this morning.
This is hard to get anything other than just it fails like a fuse. It just breaks the circuit. That's it.
And I kid you not, like, I was able to get it happen a couple times the other day.
Yeah, there's just over about 1 inch long of tape here.
Yeah, there's a consistent amount of smoke coming off of this too, blowing away from the project because the fan that's next to it.
Yeah, those, I don't think that's showing up very good on the camera, but there's...
There we
go. Yeah, more space to dissipate the heat. Ooh, and it's shrinking, it's rippling a little bit. And smoking. There we go, that's open flame.
Yeah, it's at 4.5. Oh yeah, that's a significant amount of smoke coming off of that. Sorry, Ben, you're getting the brunt of it there. Huh, it's lasting longer than I expected.
Oh, it's just smoking away. Woo, that's really smoky. Wow. And, oh, there we go.
Huzzah!
Nice thing though is fire does not conduct. Breaks the circuit. Cool. We repeated the experiment a number of times in slow motion and as a close-up until we finally got open flame. Okay, Josh, that didn't go exactly as we expected. So what did we actually learn from these experiments here?
That running amperage through tape can be very anticlimactic, and that,
Can?
yeah, copper foil tape is a really, really good conductor. We threw 5 amps of a current through it, and it didn't even heat up anything noticeable. It's still below body
Right, and
temperature.
it's metal, and it's going to spread out that heat similar to like how aluminum does.
Exactly, and I kind of figured that would happen. It's still copper foil tape, it's weak, it's annoying to work with, but it does conduct a high amperage really well. Then again, 5 amp is more amperage than anyone's ever going to reasonably do on a paper craft or craft project.
Usually you're just going to be running a couple of LEDs, something like that, just milliamps.
That would be like 80 LEDs on this RGB LED string going full power, and that's a lot.
That's blinding. That's like Christmas at the Griswolds right there.
It's annoying. Our nylon tape, though, was really interesting. Instead of starting on fire, we found out that it actually ended up acting like a fuse, where it burned itself out when we got to basically a dangerous level. And running an amp of power through it otherwise worked out just fine. So that was nice to know, but the fuse aspect was kind of interesting. We actually had a hard time getting it to heat up to like interesting video level.
Yeah, it really behaved more like a safety device than like a, oh dear God, this is a dangerous sort of a thing.
Exactly, and an amp of power through nylon tape, that's over 100 LEDs, like little tiny 5mm, 10mm LEDs. To be like over 100 of them, which is insane to run in any sort of papercraft project or other thing. So we're well into the range of kind of insanity at that point, but it works just fine for everything else.
And again, the whole idea here was really that we wanted to test destruction, do this kind of way over the top from how any of this would ever be used.
And yeah, just know the limits of what our stuff is. And oddly enough, it did manage to handle 5 amps of power for a brief moment when we had it really close together.
Well, I kind of do have an idea for how to set the stuff on fire, except it doesn't involve electricity. But if you literally just have a source of fire, it will absolutely burn. And frankly, this was way easier than trying to get it to short out with the electricity over here.
And the nylon tape is just in general so much easier to use. It's flexible, durable,
Very
and
strong.
You can put it on shirts and it moves around. That's why I like it over copper foil. We just know that
Reusable, works as hinges and things.
It is, yeah. It just solves all those annoying issues copper foil has.
Which tends to tear, for example.
The only good thing about copper foil is you can solder to it, but at that point you're soldering to tape, which defeats the purpose of using conductive tape in a project if you're soldering to it. So, yeah.
Any last words here on this tape testing experiment here?
Not really. It worked out pretty well, and also it was just really hard to actually get anything interesting on the video side of things because it kept
We got
burning
like the
out.
one slow-mo shot. I mean,
We did.
It took a while.
But-
What was it, 4 hours now, I think we've been working on this?
Yeah, it took much longer than we expected to actually make something interesting happen.
Yeah.
A lot of burnt out fuse effects going on, but that's nice to know too that it will cut itself off before it gets to a dangerous level.
And again, we seriously had people saying, hey, how much current can you put through conductive tape? So
Now we know.
now we know.
Up to an amp before things get annoyingly hot.
And kids, don't try this at home. Let us do it.
Let us be dangerous
Let
in
us
this
be
wonderful
dangerous
setting
and
with a fire extinguisher.
So if you want to learn any more about this or any of the various projects from Brown Dog Gadgets, check out browndoggadgets.com, and we'll see you next time. Like, comment, and subscribe to stay up to date on all our latest projects.